Well, luckily this time I noticed that my 15 minutes were almost up. So I stopped the last video, perhaps a bit abruptly, but now we're gonna continue talking about iterators. But I just want to go back and point out one thing that you might have noticed. So in the iterator class, right, we have the list that we get through the constructor. And so we access the fields. Well, sorry, we access the methods of the list. But here, look, we're actually accessing the field directly. This is a field of the list. Here it says, right, explicitly. That is not a field of the iterator class. So if this field were private inside the list, we could not access it like this. But in our list class, the fields are set as, oops, that's the wrong list class. Sorry about that. Here's the AB list. The fields are protected, which means that any other class in the same package, which means in the same directory, can access those fields. And obviously, we're going to put the iterator into the same class as the list because they actually are really very closely coupled. This only exists to work with the list. So I just wanted to point that out in case you noticed that and said, hey, how come we're accessing the field of some other class? And that's why we are able to do that. So let's move on to talking about moving the iterator into an inner class. An inner class is a class inside of a public class. So it can't be public itself because the name of the file has to match the class name. So that would be the list class. That's the public class. But we can put a non-public class inside the public class. And then, of course, it's going to be inside the same file. So why do we do that? We do that because it just doesn't make sense to have them be two separate classes. It's the iterator class really only exists as part of the function of the list class. So we put it inside the list class. So the iterator class is inside the list class. So this does a couple of things to our iterator. First of all, since it's part of the list class, it's a member of the list class, so it has access to all the fields in the list. That means that we don't need to pass the list to the parameter anymore. To the constructor anymore. Before when we created the iterator, we passed the list saying, hey, I want you to iterate over me. Now, since it's inside the list, it already has access to the list itself, and so we don't need to pass the list object, to the constructor. So that's one thing. Another thing is, this is the way inner classes work. It inherits the generic parm of the enclosing class. So the inner class doesn't need to have a generic in the class statement. We can still use it inside the class, but we don't need to put it on the class header. So here is an example of what the iterator looks like when we have an inner class. So here is the public class, the list, and I abbreviated. I left out the fields and methods. Here's the iterator method of the list that says, create a new iterator object for me and return it. And the only difference we see here is that before we had to pass the parameter, right? Before we had to pass the list itself saying, hey, iterate over me. Now we don't have to pass that because it's going to iterate over this list. It's part of this list. Okay, so then we have all of the other fields and methods, and here's the inner class. So it's actually inside. Look, here's the end of the list class, and this class is contained inside. So let me show you a more complete example. Here's the list class, and here's the iterator method, and here's the iterator right inside the list class. Not public, it just says class. It implements iterator. It is an iterator, which means it has to have has next and next. So the constructor doesn't need to do anything. We initialize previous position the same way as before. And our has next and next methods are the same as before, except that now we just access the fields directly. This is num elements, the field of the list. And here we have elements, the field of the list. So since we are inside the list class, we can access those fields, and they will be the fields of the actual list object that created this iterator. Okay. The way that we use the iterator, as in the example that I showed you, is exactly the same, whether it's an inner class or not. Because to use the iterator, we call the iterator method for that list. And that iterator method is going to create the iterator appropriately. Either if it's an inner class, it will create it like this. And if it's a separate class, then, oh, I didn't show that one. If it's a separate class, it will still call the iterator method. Here it is, I found it. It will still call the iterator method, but it will create the iterator object by passing in itself. But when you use the iterator, just to reiterate, it's the same either way because you call the iterator method for that list, and that method will do what it needs to do to create your iterator. I have an iterator exercise for you, and in this exercise, you're going to create an iterator for the linked collection. So you will need to create an iterator object. We'll start out with an iterator in a separate class. And you need the has next and next. In this case, though, there's no array. There's no num elements subscript. Instead, it's the linked collection. So we have the nodes, the list nodes that we have to loop through. So you won't have this previous position as an int. Think about what you need to keep track of your position within a linked list. And you'll be using that instead of previous position to tell how far you've gone through the collection and whether you have reached the end of the collection. So you will see that. And in the exercise, we're going to start with it in a separate class, and then we're going to make it an inner class. So the last thing I want you to do in this handout is think about the complexity for the array-based list and the link-based list. Look at each of these methods and think about the best case and the worst case. And remember, in both the best case and the worst case, we have n elements in our list. So n elements in an array-based list, n elements in a link-based list. Best and worst case for each of these. And that is what we're going to cover on lists, although we do still need to talk about sorted lists. That's the next step. Okay, take care, everyone, and be safe, and I'll be back with you soon.